The next question we have from a linear equations worksheet is this question here, where we've got a triangle of PQR, 4, 7, minus 2, 5, and 3, minus 10. Now here we're going to draw out our rectangle, our rectangle coordinate axes, and it's going to be a triangle. So here we're going to have 4, 7, which is going to be about here, minus 2 and 5, which will be somewhere along here. So this is minus 2 and 5, and then we've got 3 and minus 10, which is somewhere down here. And this is P, this is Q, and this is R. Now sometimes drawing it out visually might help, other times it might not be useful. It depends on what kind of learner you are. The first thing we're going to look at then is the length of each side. So to calculate the distance, which is the same as the length, essentially is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared, and square root it. Then the next step we've got is just to plug it in. So the first thing we've got is PQ. PQ is equal to the square root of 4 minus 2 squared plus 7 minus 5 squared. And this is equal to the square root of 6 squared plus 2 squared, which is equal to the square root of 40, or equal to 2 root 10 if you plug it into your calculator. The next step we've got is, or the next distance we're going to do is QR. So QR is equal to the square root of 3 minus 2 squared plus R minus 10 minus 5 squared. So altogether this would equal the square root of 5 squared plus 15 squared, which we can simplify down to equal the square root of 250, or equal to 5 root 10. And then the final one that we have is going to be PR. So PR is equal to the square root of 4 minus 3 squared plus 7 minus 10 squared. This is equal to the square root of 1 squared plus 17 squared, which is equal to the square root of 290. So these are your distances, and then the next step we've got is to verify that this is a right angle, or there is a right angle in the triangle. So to verify that there's a right angle in the triangle, there are lots of ways to do it, but the simplest way would be to assume that if the right angle holds, then Pythagoras exists. So that means that if you had the two smallest ones, 5 root 10 and 2 root 10, then this one here should equal 290 when we do Pythagoras. So Pythagoras' formula is a squared, which is the hypotenuse, equals b squared plus c squared. So here a squared is equal to 2 root 10 all squared plus 5 root 10 all squared. If you plug that into the calculator, then we get 2 root 10 squared, which is equal to 40, and then we get 5 root 10 squared, which is equal to 250. So therefore a squared is equal to 290, and therefore a is equal to root 290. Therefore the triangle has a right angle, as it satisfies Pythagoras' theorem. And then the final one that we've got is the area of the triangle. So the area of a triangle for a right angled triangle is as follows. Again, we'll redraw it as not exactly the same as in the coordinates, but we don't need to, because we're just going to prove an area. So here we can represent the triangle like this, with sides 2 root 10, 5 root 10, and 290. If you notice here that this is essentially half a square, so the area of a triangle is simply going to be half times B times C, where B and C are the two adjacent sides to the right angle, and therefore that's equal to 1/2 times 2 root 10 times 5 root 10, which is equal to 1/2. 10 root 10 times root 10 is 10, and then 5 times 2 is also 10, so that's equal to 50 as a final answer.